A generator object is an object that can be used in the context of an iterable, like for instance in a for loop. Let's take a look at how this is done in Python. We'll make a working copy of generator.py. We'll call it generator-working.py. We'll open that up, and we see that here we have a range object being used in the context of an iterator. So O is getting assigned this range object that's a range of 25, and it's being used in the context of this for loop, which is an iterable context. And if I run this, you see that we get a series of numbers from 0 through 24. And this is how range works. Range is non-inclusive, which means that when we ask for a range of 0 through 25, what we get is 0 through 24, because it's up to but not including the range we specify. Range takes 3 possible arguments. It only requires 1. And so those 3 possible arguments are the start and the stop and the step. And so if we start at 0 and stop at 25 and step by 1, this is the result that we get. And so start and step default to 0 and 1, and all you have to specify is the stop. If I were to start it, say, at 5 and step by, say, 2, save that and run it, we get 5 through 23. Again, we don't get 25 because it's non-inclusive. You see they're stepping by 2. So what I'd like to do here is create our own range object as an exercise to learn how to create a generator object in Python. It'll work exactly like this one, except that it'll be inclusive. We'll always get that last number there. So we'll go ahead and reset this to 25, and we will start creating our class. So we'll call this class inclusive range, and it will have a constructor. And it will have an iterator. These are both special method names in Python. Init with the 2 underscores before it and after it are for constructors, and iter, like this, with 2 underscores before it and 2 underscores after it, makes the object an iterable object. And so this is where we'll put our generator function in here. The constructor will need to be able to do this weird thing with the arguments. The first argument and the third argument are optional, but the second argument is required. That's going to take a little bit of manipulation on our end, and we'll do that in the constructor. We need this arbitrary list of positional arguments. So we'll use the list argument syntax here with an asterisk and args, and we'll get the number of arguments by using the length built-in, len, args, like that. And if we have less than 1 argument, we're going to raise an error. We'll use type error. Requires at least 1 argument. That's if numargs is less than 1. And we'll use elif, numargs equals 1, elif numargs equals 2. I like to outline my code like this sometimes and then go back and fill it in. Numargs equals 3, or else we'll raise a type error. Expected at most 3 arguments, and got this other number. Now we can go ahead and fill in each of these conditions. If we get just 1 argument, then we know that's the stop. So we can say self.stop equals args sub 0. Otherwise, we've got self.start equals 0 and self.step equals 1, because those are those default values. If we have 2 arguments, then we know that that's the start and the stop. Self.start, self.stop, and we assign that to args. And we use our default for step. Finally, if we have 3 arguments, then we know that's all of them. Start, stop, and step. So now we have our constructor, and our iterator is very easy. We start by setting the starting point. Then we have a simple while loop, while I is less than or equal to the stop. Then we yield the result. We'll get back to that one. And we increment the iterator by the step. So this is what makes it a generator, is the yield statement. Yield works just like return, but with a significant difference. If I were to use return here, it would return the value, and the next time the iterator was called, it would start at the beginning of the function. By using yield instead, it returns the value, and the next time the function is called, execution picks up right after the yield statement. So the way this will run is it will set the starting point, and it'll test the while loop, and assuming that the starting point is less than or equal to the stop point, it will yield the value, so that's the starting point, and then the next time the iterator is called, it'll increment that value and test the while loop again. And then it'll yield the next value, and then it'll increment and it'll yield the next value, and this allows it to operate as an iterator. So by having the yield statement inside the function, that makes the function a generator. And what a generator generates is an iterable object. Need to change this to our inclusive range. I have a little typo here. Self.step. Save that and run it. And there we have our range all the way up to and including our stop. And so let's go ahead and test out our constructor. We'll change the start point to 5, and now it should start at 5 and go up to 25. Save that and run it, and there it is. Starts at 5 and goes all the way up to 25. Let's have it step by 2 instead of stepping by 1. Save that and run it. There we see it steps by 2. We can change that to 7, and it'll still do what we expect. That's great. And now let's call it with no arguments, and we'll test our error conditions. With no arguments, we would expect it to get that type error, and there it is. Type error requires at least 1 argument. And if we give it 4 arguments, let's say 1, 25, and 3, and 14, we expect to get this other type error here. And there it is, expected at most 3 arguments and got 4. And so we have successfully duplicated the range generator function. Save that and run it, except that ours is inclusive. It was really easy to do. So this is how you make a generator object, is by using the iter method in your class, and now your object becomes iterable. It becomes a generator. And when the object is used in the context of an iterable, like for instance in this for loop, then that iter method gets called automatically, and you don't have to do something like .iter. You can simply use the object in that context. In fact, I don't even have to create an intermediate variable. So I can take this line out altogether and put it in this place here, and you'll see that range is used like this very often. So I can save that and run it, and there we have a drop-in replacement for range, except that this one is inclusive. And that's how you make a generator object in Python. It's a very convenient and very powerful technique. You'll find yourself using it in some places that you won't anticipate. I've used it in database applications where I have a very specific database application with a specific class that simply steps through a particular type of a query. I've used it in parsing files where I want to get a certain pattern out of a file. There's all kinds of applications for this, and you'll find that you actually use it more often than you might think.